Hello, everyone, and welcome to Handmade Hero, show where we code a complete game live on stream. Folks actually found a bug for us. I'll be completely honest with you, I don't know that we are logged in. In fact, we aren't logged into GitHub here. But suffice to say, if you are on the Handmade Hero private GitHub, then you may have seen there's an issue that someone had found a bug in math code. It's a mistake I've made twice. I can't seem to get it through my thick skull on this particular issue. I don't know why. I have it in my head that a particular command works a particular way, and it doesn't work that way. And I've literally made this mistake 2 times on exactly the same thing, right? And let me show you where it is. First of all, thank you for the folks who tracked this bug down. It saves us a lot of headaches of ever finding it, which we probably would have had to do eventually, but we probably would have had no idea where it was, and it would have been bad. But we probably only would have found it when it comes time to do specific testing on the math library or something like that, which, you know, is the only time we probably ever would have even found it. But anyway, so if you take a look at our intrinsics, I believe is where they are. So we have a sign of function that we were using for F32s. And you can see here that we have a blendvps, right? And so in my mind, for some reason, blendv works by doing a bitwise combine of the source and the input using the mask. So it goes through the bits of the source and the 2 sources. It goes through the bits of the 2 sources, and it just uses the mask bit in that location to pick which bit it's going to pull. So in my mind, it's like an OR between an AND of the mask and an AND not of the mask of the 2 inputs, right? That's in my mind what it does. In actuality, that is not what it does. So if you look at the Intel Intrinsics Guide, for example, which I think we can mn blendvps, yeah. So if you actually look at what this does, you can see that it actually doesn't do it per bit, right? It only does it per lane. See what I'm saying? I do not know why this fails to be in my head. Like, this is not what the function does in my head. And I'm gonna keep making mistakes about it until I internalize this. I've literally made exactly this mistake before in at least one other case I can remember. And so this doesn't work for sign of, right? So we can look and we can see where our blendv PS is at. Oops, I should probably search the whole project. blendv PS. So we can look here at where this value actually is, and you can see we've got one in SIMD here where we do sign of there, and we've got one in SIMD here where we do, it's the same function, right? Just one for scalar and one for 4-wide, and they're both the same wrong. Now, I don't actually know where we use this. If we search, probably not in a lot of places, because we would have seen this bug show up more often if we'd used it a lot. So you can see here inside the lighting code where we're doing our actual probe stuff here, you can see that we do a sign of there, and that's gonna be wrong. So this is probably wrong. Then we've got inside the octahedral, from unit vector stuff. I don't really know who's still calling that, because I think we may have inline most of that. But and then that's not real. These are from the shaders, so those are different. They are using the shaders version, not ours, right? So at least I think that's true. Let me just verify. But it wouldn't matter because this wouldn't use a blendv anyway, right? They're in shaders. So you can see like this will be adversely affecting our lighting. I don't know that it has anything to do with the lighting bug that we had, but you know, because I can't think of a lot of ways that would actually be the case. I can't think of a lot of ways that would be the case. Yeah, I don't know. I also don't know if this would have affected our octahedral lighting pattern, right? Because if you look at generate octahedral lighting pattern, I don't know if this direction from txty, right? That's the direction from txty and get octahedral offset. Those could be implicated with this as well, in which case we'd have to rerun the generator. So you can see, yeah, in fact they are, right? So we've got, in both cases, we've got, we just have this sign problem here. And so what I want to do is go ahead and fix that code just so we don't have this issue. It might also be nice at some point to merge these two. Like, it would be nice if we didn't have two sign-of functions because, you know, we probably could get away with one. There are some issues because you kind of want to do PS versus SS in these cases. And so I don't know to what extent we want to, you know, try and go down that route. But, like, this should really be an SS, unless they don't have one of those. Do we not have one of those? Is that why that's doing that? Yeah, okay. But the and stuff and the or would do that. So anyway, this is what we need to do. We would like to take the sign of this value, and what we want to do here is we want to basically keep the entirety of the input, but we want to just replace the top bit, right? That's all we wanted to do. So we're trying to take this mask U32 here, and we're trying to basically do an like and not probably, right? So we're gonna try and do an and not to clear it out, and then we're gonna do an or, right, to knock it back in. So we want to just knock that into a value that's all ones, which we already have. And so this doesn't need to get masked out, right? So we can take the value that's all ones, and then we can make something called sign only, right, that we produce here, that only has the sign bit. And when we OR the sign bit into the ones, it will flip their sign as necessary, right? So that's all we really needed to do. And so what we need to do here is just pull out the sign value. And so we have to look up, I never remember who gets knotted in the and not. I don't remember if it's the second parameter or the first parameter, right? So somebody gets knotted, and I don't remember who it is, but we can take a look. Yes, you can see the and not here. Actually, that's... Huh. So... I'm a little confused. Is there a reason why Skylake is no longer listed on here? It's there. Did they just never update these for Skylake? I guess I've never looked. Anyway, I'm assuming that it's 0.33 on Skylake, although maybe not, because this is 111 for throughput. So actually, based on that, this looks maybe like a bad idea. Oh, no, that's right. Never mind. We don't need to and not that. That's the correct thing. Right? I take it back. We only need to and it out. correct? Because if we AND this out, then it will just be the sign bit. So we don't need to AND not it because we don't have to process this at all otherwise. So if we load that in and we mask off just the high bit and then we merge it in, we should be good to go. In fact, we can just do this, right? So that seems good. That all seems good to me. And so let's just go ahead and finish this off. We need to extract the result, obviously. So there we go. I might make this be a two-step process because that line is getting a little long in the tooth. So maybe I'll just grab this out of there. And we could do this just to make it a little easier to read, right? Just helping peeps out. So if we look at what this does now, we basically say we need 1 because we're trying to get a sign here. This is not sign or 0, which I thought we needed. So now I'm a little weirded out because I don't know where that went. Because we had that, didn't we? Like, what happened to sign or 0? I'm kind of weirded out about that because I thought for sure that you needed to have the sign for that octahedral where you did a sign or 0. And maybe we like reorganized the code. Did we... Like, did we do something else here? Because I really just don't remember. I guess, is what we did just say that sign of is always sign or 0? Like, meaning this just always produces sign or 0? Or something? Because if that's the case, then this is also wrong. So I'm just a little confused. Like, I thought I recall the sign of having to be -1, +1, or 0 if the input was actually 0. And I thought that was a requirement for the octahedral stuff, but maybe I'm misremembering that, right? But I seem to recall that that was a thing that happened, right? So I don't love that, right? I don't really know what's going on there. So it would be nice to know what was happening. That's one to go back to the episode because I know we should go back and watch the video because I know that that was something that was an issue, and I just don't really remember. Does anyone in chat remember? Yeah, probably no one remembers. That's all right. So this part is weird, and I think we kind of need to take a look at that. So I'm just going to put a to-do in here, which says to-do, look at octahedral code and figure out if we're actually using sign or 0, or sign for sign or 0 in places. Because I don't see a sign or 0, and I feel like there should be one. So yeah. What else do we need to do? Okay, so it looks like these are only in PS land. Okay. So in this case, we've now got a sign of that should probably be more correct. Let's take a look at it really carefully to make sure, and we can also step through it to see if we've got it working a little bit better than it was before. So in here, we have the mask, which is just this like mask U32 with the high bit set, right? We then have a 1 that we load. We and the mask with the value that you pass in, which the mask is all zeros except for the sign bit. So that should leave us with just the sign bit that was passed in, right? So just the sign bit of whatever this is. We then combine that by ORing it in to the 1. So we flip the signs of the 1 basically based on where they were flipped in here. And of course, we're only doing this for 1 lane right now, but we're going to have it for the 4 lanes as well. And then we like extract the value back out. Now, there's another sign of function. There's one. Oops. It would be nice if these showed the where they are in the files. Yeah. So here's the same function, right? And so we can, if we want to, just change this one to basically be the exact same thing, only instead of ever there being a SS, it's just a PS everywhere. And I think that is the whole of it, I think. Sign bit and PS set SS value.p. What is the problem? Cannot convert argument 1 from mm128 to float. There we go. So I think this should be the equivalent for it in 4-wide for our little F32S4X there. So this will do the correct sign, I believe. And here's sign bit from. I don't know why sign of isn't just using those. Those were written correctly, as you can see here. So yeah. Anyway, so we could just have this call sign bit from. In fact, maybe that's more sensible, right? Like right here, we could just say, well, we just need the sign bit. So we just say sign bit from, like so. And that gives us the sign bit. So we just OR the sign bit with 1, right? And that's the result. Probably. I also don't know, like, do we just have an operator OR anyway? We do. So really, you could just write this just directly. So the other thing we could do is just say, oh, like, actually, the result is just this. And I don't know what we have for set calls in this particular world, but yeah, so it's just this, right? Oops. So we could just do that, where we load a 1 and then we OR the sign bit. Oops. I gotta work on the new forecoder thing doesn't do tokens the way I expect. I have to go figure out how to fix that. Not sure how. Anyway, so I think that would basically do it. And in theory, if we run this now, we presumably won't really get, because since we weren't super able to perceive that error to begin with, running it or not running it is not really going to tell us anything anyway. But you know, we can at least verify that things didn't completely destroy themselves, right? So that all seems fine, right? This looks like it's running the way that it was before. Unfortunately, we don't really have a way of looking at this code in a, we don't have a way of like reproducing our release lighting bug. So there was some question as to whether fixing the sign bit error would actually fix the lighting bug that we were encountering. And the answer to that is that we just don't know, right? I mean, we hadn't tracked down that bug yet, so we don't actually know. We don't have any expectation of whether or not that would fix it. So I'm sorry, unfortunately, I can't. There's no real way to reliably provoke that bug. It's entirely possible that it was because of that. Like there was something that was writing garbage in somewhere or who knows what. As a result of that code being totally wrong. But we don't have a way of specifically provoking that bug at the moment. So unfortunately, we can't really, we just don't know. So we're going to have to still look at that and see. But, you know, that's just where we're at the moment. So yeah, thank you for reporting that in. I'm going to go take a quick second to just look through that code and make sure that it's now doing something sensible, because we know that it was wrong and we just kind of slapped in a fix for it. So I'd like to just make sure that it's actually correct at some point, or at least like step through it at least once to give myself a little bit more confidence that we actually fixed it. And yeah, so the retail lighting bug that we were having before is not there at the moment. Let me look. So the spec valid diffuse valid thing though still is a bit weird. It looks like that was still set to bogus values there. See there's like spec valid, diffuse valid are both 0. And they both knock on to 1 as we move. So I think there's probably still issues there. Like there may be a situation, for example, where I think we have a situation where we're not like clearing the lighting. Because remember, we're trying to be pretty minimal here. There's not a lot of safeguards in the lighting code because it's trying to be performance oriented. And so we don't have the luxury of doing a lot of like clearing or, you know, things where we're spending extra CPU time to make sure we don't have stupid errors. We don't really have the luxury of doing that, right? Everything's got to be kind of a little bit bare bones. So given that fact, I still, yeah, there we go. I'm like, I still suspect the bug is there. We just can't provoke it. And so there you go, right? And so I think that we still should keep looking for that error. And I think there's some issues there, right? Now we may, and I don't know, but we may have gotten a quality improvement as well. Oh, check that out. Look at, there's the bug in like a localized way, right? We may have gotten a quality improvement from fixing that sign bug. Like probably what happened, like we could go back and compare by like flipping the sign thing back to being wrong. But we probably got better, like more uniform lighting or something. You can see that there's still it kind of feels a little bit like there might still be some bugs in there. We haven't really done a careful pass on lighting, but we probably had some asymmetry that was getting introduced by that sign being wrong. And by fixing it, we presumably got a more correct distribution of the light, right? So that presumably happened, but you know, we, like I said, we were just trying to fix that bug. We weren't really trying to improve the lighting quality. That may have just been a byproduct that happened because that bug would have been making things worse, right? Would have been making the lighting look worse. Similarly, like we have very boxy interpolation of the lighting right now, which I wanted to fix for a while, but that's sort of a separate issue. I don't know where it's coming from is the problem. Like obviously it's coming from the fact that we interpolate the lighting based on the like cube boundaries there, but it probably shouldn't quite look like that, right? And so that's kind of another thing, but that's separate. So we have plenty of lighting quality things to do. For right now, I want to look at that, right? You can see you get these weird artifacts that come in, and we just have no idea where they're coming from. So what I'd like to do is get just spend the rest of the day seeing if we can get a better way of looking at the state of the light map so that we can figure out where those values are coming from, right? Just some idea of where they're coming from. And I think that it only happens in release mode. So for whatever reason, if this is set to OD, we don't really see it happen as much. But to be fair, that may just be because we don't run enough frame. Like, you know, the debug mode is very slow because the lighting is slow in debug mode. And so it may just be like that it's hard to provoke because you need it to run, you know, fast to run enough frames to hit the bug because it's periodic, right? So I think that's kind of, you know, I don't want to put too much stock in that. I mean, you know, it's because it looks like the lighting basically looks the same in both modes. I don't see like a lot of difference between them, which is why I'm not really sure. Is the spec valid, diffuse valid? Does that happen in debug mode the same way as well? Would be another question. You can see those like spec valid, diffuse valid values are not wrong. And like it sure, so that it's a bit troubling because, you know, if I set it to O2, like yes, the bug isn't immediate, like we don't see the bug immediately, but like those values start out at 0. Right? So I would like to know what's going on there. And so I want to take a look and see, like, is there something weird going on that is not what I would expect to have happen? Like, how are we getting those values written in there wrong? And so I want to go ahead and look at the light atlas. Like, here's the code in validate atlas that tells us when a texel is wrong or whatever, right? And so what I'd probably like to do here is just have the validate, like I'd like to have a thing that validates texels. And this is just checking to see if they're negative, right? And they really never should be. So I'm just going to do here a validate texel. And I'm going to have a texel that you pass in here. And I'm going to put this code as validate texel. Like so. And I'm going to put that in a way that we can call it on a single texel elsewhere in the code. So let's do this. Why does it do that? So the indentation in, yeah. I want that may have been fixed. I have to update the forecoder as well. I should do that like after the stream today. We should like update our forecoder and the new forecoder flurry, and then send the things that are still not working to Ryan and Alan just to see what the status is on that. Yeah. Okay. So let's go ahead and do this and see what happens here. This is, oops. This is more correctly written as suchly. So what I now need to do is this validate texel call here. I want to be able to do that anytime that we're like writing new texels. So like, for example, in here you can see this block copy thing where we do like copy tile or zero tile, right? We could put in a stopper here, for example. In fact, that seems like a good idea now that I think about it. So we've got this validate atlas thing. Maybe one thing we'll do here is like, I'll put in a some assertions. So like when we do block copy atlas, I will do like a assert. So this is just going to be an assertion like in and out. So what this will tell me is just, does the block copy ever like screw up the atlas? And so what we can see here is that like I put one at the top and one at the bottom. And the reason for that was to see if it ever screwed up the atlas. And what you can see is that we're hitting the top one, which means that block copy atlas was not implicated this time around. Somebody else was the reason why, like somebody's passing it in. It had already been mucked up, right? Block copy atlas didn't muck it up. And if we run this multiple times, it's actually kind of nice because we can see that it just happens every time, right? Or, well, not, I guess not quite every time. It happens often, right? So often when we run through there, we will hit that validation fail. That means I can more or less leave this routine out for now, meaning I don't have to worry like if this thing is like what's corrupting it, because we now know it's happening before it ever does the block copy atlas for whatever frame the first frame is that gets borked. We never saw one where it came in okay and then left borked, right? So that's helpful because it lets me go, all right, let's focus on somebody else then, and let's see who else is writing to these, right? So when we make the atlas as well, like you can see here where we do make light atlas, that doesn't actually set the atlas texels. When we actually go to set the light axis texels, we could validate the atlas there. And that is just something we might as well do for, you know, just to make sure that it's set to zeros to begin with. And you can see that like that just does not trigger any problems, right? So we're pretty sure we're starting up with valid. We could leave that one in there, in fact, if we want to. All right. And what's going on with our light atlas assert right now? So the light atlas assert is even defined in. In fact, I could just go ahead and put these in there, and then we could define it out, right? We have to remember to actually do that. So our light atlas actually has a bunch of assertions it shouldn't have. All right. So we can put in some of these, like we can put in these calls, like to just do light atlas asserts that will then turn off at the end, right? So here's us doing a bunch of validation, and we think we should basically determine, you know, from that the light atlas code itself is not causing the problem here. And that when we do cause the problem, wait, how did that not happen? Like, is this not working or something? That should have triggered, right? We just saw it happen. What's going on? Okay. That should be the exact same code, right? Very scared right now. Okay, so it was just the fact that it just didn't happen to do it that. Okay. Whew. I thought for a second, I'm like, what is going on? Okay, so in theory that should be fine now. So now what I want to do is try to find I want to try and like when I look at problems like this where I just don't have any idea what's going on, right? So if I'm approaching a bug and I don't have a theory, like I'm not testing, there's no hypothesis. It's just a bug. I don't know where it comes from. I just know that there's a bogus value getting in here somehow, and I have no idea how, right? It could be a correctly written equation that was just ill-conceived that produces bad results. It could be typos in the code. It could be something like the sign bug where I thought an instruction did something and it didn't, right? It could be literally anything. All I know is that there's a bad value, but I can sort of detect the bad values by just saying like, look, intuitively speaking, I should not be able to get negative values into this light atlas, but they clearly are. Why don't I just go hunt for negative values? Then what I'm doing here is I'm just thinking of like a set of pincers, basically, right? And what I'm going to try and do is just keep narrowing down the places where the bug can be by validating the atlas in like sections of the code until I find a place where when I enter the code, it validates, and when I exit the code, it doesn't validate. And I'm going to keep closing those pincers in until I zero in on the block of code that actually is causing the problem, right? And so by doing that, I'm hoping that we will be able to narrow down our search before we start looking at code, because otherwise it's just like it completely, like I have no real way of pinpointing anything in the code because any of the code in the entire Lightning update could be wrong. And so I want to keep trying to refine that down as small as I can get it, because the smaller I can get those pincers to start with, the easier time I'll have like debugging the code. So that's what I'm doing. Okay, so we now know that if we validate the atlas, we know that we're coming into the block copy wrong. So we're assuming that that means that like the Lightning update itself is what's writing in the negative values. And so we can start to look at the code that actually writes in these things. And you can see here that I believe there's only really two places where we ever update these things, and I can validate both of them and see if I get a clean, like enter clean, exit dirty out of those. So one of them is where we update the spectexels, right? And the spectexel atlas gets updated in here. And I think this is the only place, right? So I think that the only place the spec atlas gets written to is in grid raycast. I mean, other than the block copy we already looked at. The grid raycast will update the spectexels. So every time we enter a light atlas texel for spectexel there, so here, right, you can see it writing in, it loads out the texel here and writes the texel here. So we should be able to validate the texel right there and see very clearly whether or not the spectexel gets updated to negative values there. And then even if, so we can see if that enters clean, exits dirty. Then we can also look, because even if that actually happens, there's another thing we could do is we could validate the thing we're actually blending towards, right? Because it could be that the spectexel, the spectexel itself is just getting blended with like a negative value and going towards zero, which would mean that it's really just this code up here that's screwed up, right? And so on and so forth. So we should be able to validate this code very heavily. Now, in addition to that code, we also have all this other code like here that does stuff with texels, like filling in the borders of places on the octahedral map, and the thing that takes and blurs out, right? It takes the spec and blurs it out to produce a diffuse map. So the thing that basically takes the spec map and produces a diffuse map from the spec map, that also can be busted. So those are all of our points, and we can really start to narrow this down. So the first thing I'm going to do is just put in assertions here, where we're going to do a validate atlas on the spec atlas and the diffuse atlas. And what we should be able to do here is where we validate these on like the full cast, right? This is going to make this code run very slowly because we keep validating the atlases all the time. I don't care. We're just going to validate these atlases multiple times inside here. I should probably also turn off multi-threading to make this a little bit easier on us. So we'll do that in a second as well. But we'll go ahead and do the full cast here. And then we'll do the blur update, and we'll validate again, and then we'll validate again, right? So now we're just validating. We're having a validation party, right? Konnichiwa, minasan! Validation party. Sorry, I've been watching a lot of Mr. Yabutan lately. Hontou ni bikkuri shita. Let's see. So now we're just doing some stuff, right? We're just validating. We're validating a lot. And so, and we're in release mode, right? Because we want to be, yeah. So we're validating a lot. We're just hoping we crash somewhere, and we do. So here you can see us entering the validation, doing the full cast, exiting the validation. Assuming that I didn't screw anything up here, it means that we don't really have to think about this code, right? Because we validated the atlas after each of these, right? And we know that we entered clean to full cast and exited dirty, right? So enter clean, exit dirty, full cast means that now I'm just going to assume, for sake of argument, that we don't have to think about the rest of this code here. We can just focus on full cast itself and start to look at problems with that. So inside full cast, what I might do, since I know that that is the case, I might just go to full cast itself. Full cast is working on a specific set of tiles, right? Is how this is working. You can see it here as it goes. We assume that since the diffuse atlas is validated, that it cannot be the source of incorrect values. Our reading from it could be broken. So we could end up with incorrect values that we're getting because we screw up the lookup into the diffuse atlas. But we validated the atlas itself, so it should not actually be producing negative values itself. It would have to be our reading from it that was broken. But let's take a look now at every place where these atlases are actually used and go from there. Also, I don't know why we're passing in the tile when we also pass in both atlases, but you know, that's just, I guess, the way we wrote this routine. Oops. I don't know what's going on here. Okay. So what I want to do is try to validate now on a texel by texel level so we can catch specifically what piece of code is causing the problem. Like we know that now, or at least we think we know, that inside the full cast, someone is producing negative values, right? And what we want to do is we want to take those, the individual steps as best we can and start to see like who's producing the garbage. Now, if we take a look at here, you can see us doing some stuff like looping through these spatial grids and so on. None of this stuff should really be implicated because no matter what it does, it's just going to produce like ray intersections or something, right? So in theory, we shouldn't really care what's happening here, because even if this code is completely broken and just produces totally incorrect intersection points, the lookup code is still supposed to work. Like if you just pass a 3D position that you're like, what's the lighting at this point? It's still supposed to work no matter what garbage you did to generate it. So we should be able to find something. I'm gonna look at the chat. What is going, chat? Does nobody on the chat speak Japanese? Seriously? Nobody on the chat speaks Japanese. We don't have a single Japanese viewer. Somebody does. Somebody does. Somebody said bikurishita. Right there. Yes. Excellent. So those of you who are replying right now, who do speak Japanese, yeah, it's 5:30 a.m. Okay, good point. But there'd be Japanese people who don't necessarily live in Japan, like, or people who aren't Japanese but speak Japanese, right? And if you watch Mr. Yabatan, you know what honto ni bikurishita means, because he says it like in every single video. Somebody post a link to Mr. Yabatan. How good is my Japanese? Is terrible. Absolutely terrible. As you could probably tell from my pronunciation of honto ni bikurishita, which is probably very poorly pronounced. Somebody post a link to Mr. Yabatan. Like maybe post, if someone can, while I'm typing here, post a link to the Mr. Yabatan where he does a he does like a hot pot with his dad on the phone. Do you know what I'm talking about? If someone could post that link, Mr. Yabatan. If you don't know who Mr. Yabatan is, we'll take care of it after the stream. All right, anyway. Mr. Yabatan is great. He's like from Norway, I think, but he does like Japanese videos. And like he makes fun of people trying to speak Japanese and failing, actually. Sometimes, I don't know. You'll see. It's fine. Yeah, Foreigner Meets Ramen is great. In Foreigner Meets Ramen, he actually does, he says, he pretends to have like an Australian accent and does like what it sounds like when a person with an Australian accent is speaking Japanese, which is pretty funny. That's not how Mr. Yabatan actually sounds. Mr. Yabatan actually has very good Japanese pronunciation from what I can hear. Not that I'm a great judge of that, but him and Dogen, who's another streamer who does that stuff, they sound like really good compared to like what a foreigner normally seems to sound like to me when they speak Japanese, where I can really tell, even though I'm not very good at Japanese, you can hear the difference between a native Japanese speaker and the average like foreign YouTuber who also speaks Japanese. They sound totally different. But like Mr. Yabatan and Dogen sound like really good by comparison. You know, I'm sure they probably still have an accent, because, you know, it's probably not possible to be like 100% fluent. But like it's pretty impressive how much better they are than a lot of the people. Oh yeah, Nabe Party with my dad. That's the one. Anyway, Mr. Yabatan's catchphrase is honto ni bikurishita, which means I'm very surprised. Or like that's surprising. And I mean, I don't know how you want to translate it, but like that's what he says all the time. So I feel like that's, you know, when we find this bug, honto ni bikurishita, we're very surprised. We'll be very surprised at what it is. Okay, so we know that we're inside full cast. We've got issues, and so let's try to narrow it down here. We I really don't think that the spatial partition walk is implicated. That seems unlikely. So when we go through here and we're doing like raycasting, you can see here where we don't care what happens in here, I guess. Handle lerping towards 0 in case where we ever have moving occluders. So what happens in that case, actually? What do we produce? So nothing. Okay. So we actually like just don't do an update in this case. So in this case, I think we're fine, right? Like we shouldn't have we shouldn't really have any problems there. So maybe let's do this just to make sure that the problem is actually in this case, because it should be now, right? Okay. Here we go. And this is just validating around that block. Yeah. So again, that's what we want to see. Remember, pincers, we're just pincing down. And what we want to see is we want to see enter clean, exit dirty, right? Now, before I go any further with the pincers, I want to turn off multi-threading. The reason I want to turn off multi-threading is just because if we don't, there's a possibility that like some piece of code in some other place is doing it that hasn't entered yet, and we're picking that up on the exit. So I just want to go ahead and nerf the multi-threading real quick, just to make sure that we don't have that particular pathology happening. It's not that likely, obviously, but it certainly could. So what I want to do is where it does the internal lighting core, which is here, and it passes in the lighting queue, I want to just pass in 0 there. So maybe we'll do a thing that's like, disable. Oh, I don't know. Maybe I shouldn't do that. I was thinking of maybe making a switch for this, right? So one way to do this would be like global B32 light light disable threading. So there's a thing here that we could just turn. So we could basically like, look, oops. If we disable the threading, then you don't get a lighting queue, and you won't multi-thread. And so in theory, like, right, if I set this to true now, then it will pass a 0 there, and we won't get any threading. And mine mark 42, yeah, I mean, that's what I remember. I remember it using sign not 0. And so I was wondering, we have to go back and see, because I know we dealt with that on stream when we were doing it. So something's weird about the fact that we're not doing a sign or 0 there. And so I would like to know why. And so I want to go back and see why we didn't do that. Maybe we had a good reason, but that seems weird. So I don't know. All right, anyway. Removed multi-threading. We've got that busted assertion now. And so I'm going to go ahead and take that validate Atlas stuff that we dropped into the full cast. So here, if I go up to full cast. And what I want to do is now just validate the actual parts I care about. So you can see here, if we go down, we've got like sample direction reading. We run the grid raycast here, right, a bunch of times. And then we come back, and this is just debug code. So really, really we're talking about just this code in grid raycast. So like right here is what we think is the bug, right? So in theory, if we just validate just the texel, so I'm gonna get rid of these, right? And I want to take just the spec texel, and if we look at grid raycast, so grid raycast loads 1, 2, 3, 4, 5, 6, right? So I'll be completely honest with you. My memory of how this is running has completely paged out of my head. And so I actually don't know why that would be okay. So oh, well, okay. So it's we run through 8 rays at a time. 6 times 4 is 24. Okay. So we just do 8 rays at a time, and so that we can write out 24 things at a time. So that's fine. So that's looks like all that is, right? So that seems fine, and that just means that we have to we're writing one row, right? So we're writing the 8 texels of one row of this thing. Oh, don't let chat. Do not let me forget to rerun the sphere generator, because our sphere generator is also wrong, right? Probably has nothing to do with this bug, but again, we want to do that because it means that our casting is probably wrong. Separate issue. Okay. So when we're doing this casting, what I want to do is I want to validate all of these texels. So in here, I want to do a validate texel for each of these. So when we do these texels, I think if I look at Light Atlas texel, it should just be the row in question. You can see it here, right, where we have the value is just a pointer. So I should be able to do like validate texel like this. And we should be able to validate all of the texels in this row on entry and exit. So basically that is the validator, right? So that should validate everything, and in theory, we should be able to catch the actual like specific validation, like the thing that failed. And that should just work, I think. Now, again, don't quote me on that, because I don't 100% know. I mean, I think that should be the case. So I'm going to try and run it in debug mode and just see if we can get it. Or if it only happens in release mode, which it might. Which really sucks. Because I don't really know like why we would only be getting release mode here, if it has to do with some kind of optimization that's happening. Like I just don't know, what would be causing this. But you can see pretty clearly like we're not getting anything there. But then when I do an O2, oh, okay. What? Such a weird bug. So we were having a validation fail right away, and now magically it wasn't happening. So we really have no idea what the heck's going on here. If we believe this code, where we're validating the texels, you can see here that like it seems incontrovertible at this point that this is blending towards a 0 value, meaning that transfer PPS had to be negative. The only reason I say that is because if you look at the validate textile calls, even if this is validating garbage, meaning even if this is like off the end of the array or something, right? It validated here and it didn't validate here. It's the same value, right? So I mean, I don't know how else to look at that. Now, this is an F32 4X here. So there's something a little wonky. If we're writing 24 values, this is too many. Right? Is that right? No. No, that's right. So 5 times 4, yeah. So in theory, that just means that this wrote out the last 3 values of this F32 4X, the last 3 values, the last RGB set that was written out there, was just plain wrong. It was negative somehow. And if you take a look at this code here, all it's doing is doing a 1 minus blend value, right, from S0 to T0. So the next thing I feel like that we would want to validate is that there are no negative values in transfer PPS. Now, transfer PPS may be directly inspectable by us still at this point. I don't actually know. Or it could be complete hogwash. So I don't know, this is what it's telling me transfer PPS is, but don't know if it actually is that or not, right? If I go up and look at what transfer PPS is, it's uninitialized, right? So, like, one thing I don't know is it always actually processed somehow? Because that, if it wasn't, right? Like, if there's a way to get out of this routine without setting transfer PPS, that would be a real doozy, right? That would do it, presumably. Now, there's one real easy way to test that quickly, which is I could just initialize transfer PPS, right? I could just say, yeah, it's 0 now, right? And then we can just see, like, does it have anything to do with that? And off we go. So no, right? So I mean, that could still be a separate bug, but we know we can produce it. Excuse me. Regardless of whether that's initialized or not. Now, if we look in here and we see where transfer PPS actually gets set, you can see we do a bunch of work here to produce these values, which is, I think that's us doing like blending and such. And we produce down here the transfer PPS for the array index value by reading out the transmission level of these things. And you can see us, it's a combination of a bunch of stuff, right? Now, I mean, one of the things that's kind of weird is how low these values are. They're all very small numbers, which is a little bit weird. But what you can see is that if we pretend temporarily that this is actually real, like what we're looking at here is not fake, that is just nuts, right? Like I have no idea how that value gets produced. It's complete lunacy. The rest of these values are just very small positive values, which in theory could be correct, right? If you're kind of fairly distant, you know what I mean? So I don't know what to make of that. I really don't. And we should probably just now try to track that down. And we know, furthermore, even more troubling, we know that this doesn't happen in debug mode that we can find. So, like, whatever is happening there is, like, is bad mojo on a code gen front, right? So this code is like busted somehow, and we don't know how. But it's somewhere along the lines it's broken. That suggests to me that we probably need to start pincing more because we don't know where in this code we're at. So let's continue to pinch, and let's just say, look, transfer PPS should not be negative. So let's go ahead and make sure that it's not. And now I'm just trying to move this bug one up the stack, basically, right? And find a place where we trigger this before we trigger this. And it looks like that's exactly what happened, right? So if transfer PPS is actually negative, that again helps us narrow down the code here because it means that we're not, it means that we kind of now know that the actual culprit is the computation of the transfer value, not the blend at the end. So in theory, right, we can now get rid of these, although, well, I won't get rid of them yet, I suppose. But it means I can push up this transfer here and start looking at the transfer values as they are retired individually, right? So I'm going to validate the transfers at the end. I'm also going to validate the individual transfer values as they are computed, right? And I expect that now I can hit this right away. Oops, transfer PPS, there we go. That I can hit that before hitting the bottom, right? Meaning that the actual computation of transfer PPS inside the loop is, what the heck? What? I am very confused about that. What the heck happened there? There was no assertion. It was just incorrect lighting. This is the weirdest thing. That's so weird. All right. So we're now able to at least get, sometimes, this to produce negative values, which we know it shouldn't do. So we can at least narrow down that. If we look at what's going on here, this is a multiplication. And so really all we're doing is multiplying the transmission by the hit ref, right? So what we would expect to see is that one of those two things is like if we take a look here at what these actually do, we're taking the reflection level and the emission level, we're taking a max of those two to produce the transmission level, and we're extracting the values out of it, right, for the R, the G, and the B. Why we're doing that, I don't know. What the heck? So we maybe just stopped because we were like, oh, we're not going to finish optimizing this or something right now. And that's why this thing does a RGB backout, because like it could just do it direct. Right? So that's, I don't know what that's doing. Not that I don't know what it's doing. I know what it's doing. I don't know why it's doing it, right? So that just seems weird because you would probably not do that you'd probably just do the shuffle, then the multiply wide, and leave it, right? So I think that's just something we didn't want to deal with at the moment. So let's just change that. So we can switch to doing transfer PPS wide, which would be better. And I think that's probably not very hard for us to do. But, you know, whatever. Doesn't matter. So here, when we're taking these out, what I want to do is say up here, we should be able to validate this stuff, right? The transmission level and the hit ref color, we should be able to validate. Because in theory, I don't think they should ever be negative anyway, right? Like, I'm not sure why these would ever be negative. So I just want to see which one of them is, right? In those cases. Because they shouldn't be. They should just be 0 or valid values, I think. But I could be wrong about that. So I guess we'll find out in a second. So let's see. Oh, well, we don't have a validator for those. We don't have a validator for F324Xs. So I'm going to have to make one. But let's take a look at this a little bit more carefully here anyway. So transmission level is a max from reflect level and emission level. Those are samples, right? So this is a sample from the tile set, as you can see here, where we just do a trilinear blend of all of the pieces. That should obviously never be negative because it's supposed to be a convex blend over things that are themselves not negative. So nothing in reflect level should be negative ever, right? And then we've got the emission level, which is the thing that we produce from the actual like hit. That's how much light is emitted from the thing that we hit. So we're basically taking the two and we're taking the max. So again, if reflect level should never be negative and we're taking the max, then we know that transmission level itself should also never be negative, right? So I'm gonna actually just write this for F32X in that actual code. So I'm gonna go to validate Texel. And I'm going to do exactly the same thing. So we're going to have a call like so, but it'll take an F324X and validate it as if it was a Texel, right? So I believe that if we just pass the 4 values that are in the F32X in question, that should validate those, and then we should be okay. Now, hit ref color, I don't actually know what that is because we haven't looked at that yet. So let's try to find that. Hit ref color is, where is hit ref color? Hit ref color. So hit ref color is actually a V3, so it's got like actually like multiple components, right? And so hit ref color, we would have to validate the individual pieces thereof. But that's pretty easy to do. So now, like maybe, if we're lucky, we'll be able to see which one of these things is creating the bogusness, right? And I just want to make sure, because I don't really trust this. I just want to make sure what I'm seeing here. Yeah. So our hit ref color looks like the culprit here. So hit ref color is not producing the correct thing. So that seems like it means that our tile blending is not really implicated there. And our hit ref color is just busted somehow. Now, we don't actually know much about that. We haven't looked at that yet. So hit ref color is like being selected in here, right? And so the question is just like, is something weird happening with hit ref color that we don't understand? I don't know. You can see that here hit ref color is supposed to be initialized to all ones, right? And then when we come through and we do, let's just step through the places where it's actually used. So there's the first one. It should be set to all ones. We then get to the heck does that mean? So wait a second. So if you pass 3 values, okay, so that's just initializing it crosswise. So it just assumes that you pass in, wait, no, that's not the, that's the v3 version. So that just assumes that each of these gets set to the same 4 wide value. All right, so this is just a 3x4 matrix or a 4x3 matrix, depending on how you want to think of it, of all ones, right? So that's fine. And if we validate the texel here, one would assume that that should never trigger, right? Because it's like we set the values, they should all be right. So it should only be like, what? So now transfer PPS is wrong, but it wasn't before? Or is that just because, wait, but I took, but I didn't mean to take these out. Right. Sorry, these just got removed. I didn't really mean to do that. I wanted to leave those in, sorry. So those should hit first. And there we go. So when we get the bug, those hit first, which is what we'd expect. So now we have to go find out why that hit ref color isn't getting initialized. I mean, not isn't getting initialized, is getting corrupted somewhere in here. So during this hit ref color select, so it's literally just this. Like this is the only thing that's happening. So the leaf ref color, there's only 2 things that can be happening here. One is that our select code is broken, so that's possible. The other is that our leaf ref colors are broken, right? Now, if we take a look at one of these leafs, what you can see is that it's just another v3 here, of another v3 4x. So what I could do here is just do a validation on the leaf ref color is one of these things garbage town, right? Because if we hit that, then that would tell us exactly what's happening there, right? So that's good in a sense. It means that the ref colors that are coming in off of the leaves in the actual tree we built are wrong. And furthermore, they're wrong in an interesting way. Let's just check something here. What the heck? How is that possible? Oh, well, that's just if it's a large value, so never mind. No. We would expect that to be true because we're not checking for large values, so that's okay. Yeah, that's okay. So let me see what leaf ref color looks like right now. if I can. So here's the pointer, here's the ref color, and this is just nuts. Like, what even is going on here, right? Like I have no idea what that's supposed to be. It's just nuts, right? Isn't there some way to do this? Yeah. Anyway, so if we take a look at this, comma PS. That's what I wanted. That's what I wanted. I suppose I can't do it here probably. But can I do it like that? Yeah. Okay. Thank you, George. So yeah, like there's this nice thing that Remedy does where you can see your SIMD registers. Well, not registers, SIMD data types as actual like as what you would actually expect, right? Which is really nice. So you can see this garbage here is like very garbagey. And it's the very first one in the ref color leaf here. Although I guess I don't know which leaf index we're on. So that's, I guess, a separate issue. But that just is not good for obvious reasons. So maybe, and I don't know, but maybe our lighting routine is actually not the problem here. Maybe it's really just the thing that builds the spatial index that's busted. Could be. We don't know. So here's grid build spatial partition. And if that theory were true, then it would mean that this is the code that's busted, right? So a couple things we can do here. You can see us doing some stuff where we set the ref color, right, to the box ref C and all that sort of stuff. And you can see that this is a sliced writing routine. So it's entirely possible, like entirely possible, that this code is crap, right? 100% possible. And that seems plausible, actually. All right. So what we're going to try to do here is we're going to move the validation into the... Well, we're not going to move it. I guess we're just going to copy it. So we're going to move the validation into this box code here and see if we can catch anybody doing something scrimpus in here, right? So you can see when we get down here to this cell count thing and we go through all of the cells, and for each node in the spatial grid, we try to figure out what all the leaves are. Like you can see that happening here, for example. Anytime we don't have this, we should be able to validate the run. So if we look at like this, so we've got a node here and we say, look, if it's not a bug, if it's not a terminator node, so it's not a thing that we stop on, we should be able to run through the entire set that we just set up. So this thing right here. we should be able to load out all of those and validate them. And if we can't validate them, something's wrong, or I'm misunderstanding how this is supposed to work. Like maybe you're supposed to mask out part of it or something. We'll have to look and see if there's something weird like that. But assuming that we load in these leaves that are specified here, and we look at each individual leaf. Now the leaves are packed 4 long, right? So is it possible that the entire problem here is we just don't clear them? So we just have garbage left in there? I think that may be it. It could just be that we need to clear those out because there's garbage left at the end, and we can't, like, that's not valid, right? So we don't fill the whole thing. Yeah. So what I would suggest here is just maybe all we have to do is like 0 this thing. And if we clear this out first, that may be the entirety of the problem. Evidently not. Just want to make sure I did this right, sorry. That should have a parentheses around it, and doesn't for some reason. Okay, so that should clear the entire thing. And so we should be starting off with clean values. So when we come through here and we write stuff in, let me just validate. So this validation here that we're doing, we should now be able to verify that it's clean at the outset and bogus in here, right? We should also be able to assert that nobody read past the end, right? Oops. So nobody should be able to read past the end of it. So let's just make sure that's true before we go any further. Good. And then let's try to validate all of the leaves before we start, right? So we start here. We go here. Oh, actually, so no, this is not quite right. Is it? No, it is. Okay. So we're going through all of them here, and they should all validate because none of them should have anything in it. They should all be 0. Right. And looks like that's okay. And so now I should be able to verify, in theory, that this will now trigger. So when we validate after the fill-in, perfect. And so in here, we are actually writing bogus values into this, like this box ref C stuff is bogus. And we don't actually know why. It could be that the input values are wrong, it could be that the compiler is getting confused on this lane index, right? But refcolor.x.e is like the only thing. Like, there's not a lot else that can be happening there, right? Like, if we look, we're assuming that this is cabined, yeah? Like, this should be... this should be able to trigger right around that actual code, yeah. So we should be able to crash it right in there, and you can see it happening. Unfortunately, box is not available for us. Box is the thing that we're actually getting the data from. So it's like, for some reason, we can't get that. Input boxes is what? Can we see that? And, well, I mean, that's not reassuring. So it looks like possibly we're literally just getting bogus input. If that's the case, that means the bug isn't even in the lighting code. It's in the input code, right? So if we go here and say, all right, Mr. Grimbleton, like, tell me about your input code. Like, tell me about the actual thing that feeds into this routine for box colors. What does that have to say for itself? All right, so that is supremely messed up. That means, according to this, and this could still not be the case, but according to our pincing, we have completely exonerated the entire lighting pipeline. I mean, that's what it says, right? As far as I can tell, that's what happened, right? And I don't know. Like, it does not look like that code is implicated here. So there we have it. So I don't know. I guess I will literally just move on to looking outside at the actual, like, place where we push this stuff down. We will just validate that these color values are actually correct when they're getting pushed in here, because I don't know. There's nothing else that I can see here that appear to be that I don't know where else to track this bug down to. Like, that was it. That was all the lighting code did. So like, if the renderer is handing it negative values for real, then that's where they're coming from, right? So, you know, the bugs are coming from inside the house at this point. So I'm going to validate those texels. All right, 4Coder has decided that it doesn't want to build anymore, and I don't know why. Wait. Why does it not want to build? Sometimes I don't understand. There we go. All right, let me go back to what I was doing before. So looking at these refc lines, we've got the lighting refc lines, we've got these refc lines here. And these validate texel functions, I'm just going to pull. I'm going to pull them out so everyone can call them. if it's the kind of thing you would like to do with your time, you can call them. I guess not that one, because that's not defined. And I also want to look for, there was one more, right? Is it here? There's one more in here somewhere. So we've got here, 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 oops. Validate Texel v3 declared but not defined. Really? But it's right there? Someone want to tell me what they mean by declared and not defined in that case? Tell you what, since I'm feeling generous, there you go. Okay, so now we're getting into voodoo land, because I don't know where else we're getting these boxes from. I guess we'll find out. But I'm just going to go ahead and check to see if we validate the texels at all times, just to make sure. That's in Handmade array. Surely a bug in Handmade array cannot be affecting us here. So I literally can't figure out where that's coming from now. So we're going to have to do this. Like, we've pushed back to the place where we think it has to happen, and it turns out that, like, we don't see it happening there at all. So now we have to figure out, how are we getting in here, right? How have we managed to get to this point in the code? With a ref-c that's bogus, but we can't figure out who put it there, right? Is someone mucking with the memory? Do we have like an out-of-bounds write bug? Because again, this is in the performance-oriented side of the code, so we don't have a lot of safety net here, right? You know, we're kind of in the place where things are kind of fast and loose. So we have to look at this. Maybe the count is wrong. Maybe the input box's pointer is off. I have no idea. But we now have to kind of look and see, how are we getting this and what might be happening that would cause it to be busted. So I'm going to look for the grid build spatial partition call point, which is here. You can see the input boxes. They just get passed to internal lighting core because in theory, these are just going to be passed down directly. So here's internal lighting core. You can see here that it just passes the occluder count and the occluders, right? Which is a thing that comes from the renderer and should just generally be untouched. Like, I feel like it should just be the same, right? and it's really not ever edited. So the lighting code doesn't care about this at all. And it looks like we're talking about whoever's calling update lighting, who knows. So if we go look at the world mode code here, right, you can see that it's reading it from the command buffer. It's doing a safe truncate, which means that this is never allowed to be greater than 16 bits. And we can try and verify that, but this will assert that to make sure that's true. And so the light occluders array is just coming directly from the command structure, right? So let's take a look. So if we look at who's writing to or setting up or doing stuff with this particular array, you can see that there's like an array in here. Are we checking to see for overwrites there? Would be one thing. Like maybe we're like overwriting the boundary of it. Like there's more than, like we're writing more than the max. And you can see a check there, and a check there. The only two things are occluders and lights. That's the only two things I can write in there. The checks seem to be valid. The check's in the mail. So that doesn't seem super likely, right? I mean, that looks about right. So I guess I'm going to go ahead and say I'm going to actually just put in a validator for the light occluder set. And we're going to have to do the same exact pincing process that we just did, right? We'll have to, we will have to do it. Oh, missing a cert around the validate texture call. Ah, okay. Thank you, chat. Speaking of that, I would like to change that slightly while we're doing that. Although I guess I'll do it this way for now. But I would like to change these so that this is so that we can leave these in. I'd like to make this a macro. Do you know what I'm saying? So that we just do validate texel as a uppercase, and that way I don't have to pull these out, because I'd like to leave these in. This could happen again, right? And if this happens again, we would want to be able to turn it on again. So we'll see. Whoa! All right. Not what we were expecting. This is a really strange bug. So in this case, we actually now can hit it because we added that assert. So the color of the occluder in this case, where we're reading out the cube here, is in fact weird. Now, I don't know that we can actually look at it, unfortunately, because we're in release mode. So we don't know why that would be, right? It's just complete garbage, unfortunately. As it often is in release mode. So we don't really get to see what's happening here. Now, why we can't look at these, I don't know. That is probably the value, maybe. It's hard to say, right? But if we take a look at the pieces here, there's supposedly 3 pieces. Here's the first one. Here's the second one. And here's the third one. Yeah. And if we take a look at what these pieces actually refer to, we've got flags set on these. So it's 4, 16, 16. That's only one flag set for each one. And we can take a look at what the flags actually reference in here. So there's the pieces, and they have the flags set up for them, which is like, it's not that. It's this, right? And so this one would say what it was. You can see here that, so occluder is 16. So these two are both occluders. And then the 4 is a cube. So it's like cube, occluder. And neither are lights. So they're occluders specifically. And the color on these two is correct in both cases, right? So when we get back to the code that we're actually looking at here, like if I actually go down to the push occluder call that's here, it's pushing on color, right? What was that? So here is color. I mean, I suppose that could be a bug there. I'm assuming I can't actually look at this value, right? Could look at the assembly and see. We don't know if that, I mean, that could be anything in debug mode. So match vector. What the heck is tag? That just looks, yeah, that's just wrong. So that's a bug. I don't know if it's the bug, but that's a bug for sure. So here are the things that you're allowed to look up into match vector. Tag ghost is literally just complete nonsense. So this right here is looking up into complete la la land, right? Thanks for no warning on that, compiler. Like, what? So this is a fixed length array, and I'm looking up into it with a constant value, right? I'm just reading right the heck off that array. This is an example where the compiler could easily just tell you that you were off, and it doesn't. I mean, it's my fault because it was dumb, but, you know, that's not a case of like C not having the information to tell you that you made a mistake, right? That's an easy to catch one. So not a huge fan of that. But okay. So this piece of code here is just not allowed. And I guess I don't know why that would not produce an out-of-bounds array access warning. I do not know why that would be. Because that is a puzzler, for sure, right? That is a puzzler. All right, so now we're kind of in a bad state because we don't have a way to reproduce this reliably. You know what I'm saying? Since we didn't have a way of like 100% certain reproduce this error. I'm not quite sure how to get it to happen. To validate that actually fixed it, right? because it doesn't 100% repro, and we also know that I guess that means that somebody in here actually well, yeah, I mean, I guess we really just don't know how we would validate that. I mean, how we can prove we fixed it, right? But that may be it. That may be the whole thing. I don't know. So I'm going to do some extra stuff just really quick before we finish up here, and then we'll just see if we get this bug back again, because there's really no way to prove that that was it. Because there could be other reasons why it was happening that we don't know about. So we don't really have a way to say that that was definitively the only problem. So what I'm going to do is I'm going to go to validate Texel here, and what I'm going to do is say that this is going to become like a validate Texel underscore kind of a thing, right? And then I'm going to pound define validate Texel to be validate Texel, like so. And then we are going to change that to an underscore and run. And then what I would like to do here is just say, okay, so this is okay, because that's not supposed to be an assertion, so that's going to call the underscore version. These are all going to change to validate Texel, like so. These, I don't really know if we should leave these in or not, because none of this code was actually implicated at all. So I think I may just pull those out because they really don't need to be there. Like, this code was just fine. So I don't think that has to remain for any particular reason. So then that also begs the question, does that mean this didn't have to be cleared? I think it does still. I think that was a bug, right? I think the only way that's not a bug is if you clear it somewhere else as well or something, right? I'm going to leave that assertion in. Okay. And everything seems good. I'm going to re-enable multi-threading, which I guess I could have done live, but I didn't. And then I'm going to see if we notice anything strange happening. So it seems pretty good. All right, so looks like we're okay. I'm gonna call that fixed for now. What a hilarious bug. Very interesting. I guess I don't have very much to say about that. Other than, yeah, pincers, that's why I use them. Because a lot of times you're totally wrong, like, or not even totally wrong, but when you have no idea where the code, what part of the code is causing the bug, oftentimes it turns out to be a surprising part of the code, right? So it behooves you to just figure out a way to, like, branch, basically, like, split where the code could be going wrong. And you just keep pushing that until you can find, like, a definitive answer, right? So yeah, I guess I would say that is an effective, very effective debugging technique. I highly recommend it. I highly recommend it. So in terms of validating the atlas, we probably don't want to have that be we probably want to do something like this so that we have the light atlas assert here, and we have ways of making this stuff all work off of that. So if we define this to be an assert, then it is. We can put this a validate texel atlas, and that'll do basically the same thing, right? So that way we can do assertions of the text of the texture atlas, like anywhere we want in the code. Like this. So what I wanted to be able to do is do validate texel atlas like that, and be able to just put those anywhere where I feel like I want them to happen. And that way, like if we experience weird lighting artifacts at some point and we think the atlas might be implicated, I can just turn these back on and I don't have to think too hard about it, right? So I'm just going to do this. And get rid of these. Okay. So then I can run it. And there's, it running. And I can also then now go in and change this around. So we just don't have any validation of anything in the atlas and run it again, and we should be good to go. Yeah. So I think that's good. Oops. And so I think, with the lighting now, that seems much more stable. And I think mostly the only real thing we want to do now is probably just like improve the filtering on it, right? So that it's smoother and less flickery. I'd say that's probably about all we really need to do. I wonder at what level it's not flickery now, because I don't really know, like how much blending makes it not flickery at the moment. But and we need to rerun the sphere, so we should do that as well. So the HH sphere we need to build. So our HH sphere now, we have to run this to generate the new INL that we use for, for all of our light sampling. And I'm not sure what we were passing as parameters there, to be completely honest. But if we look at the INL itself, which is this, then these should be the ones, right? So assuming that octahedron count is 16 and octahedron dim is 8, I'm assuming we can just pass 16.8 here and get the same thing out. So let's see if that's true. So I'm going to say 16.8, and then I'm going to say handmade code, handmade sampling spheres, like this. And I'm going to just see if that thing can converge on a reasonable set of outputs here. And when it does, or if it does, then we will use those, and hopefully that will provide a improvement, right? Okay. So in theory now, if I reload this buffer, which I guess I can't do. So let me try and reload that buffer. Yeah, so it's still 8 and 16. So in theory now, if I rebuild, we should have, and we don't really know, but we should have fixed, like the sign bug in theory was making that routine worse as well, right? We don't know that that's true, and I don't see any particular improvement in the lighting here, to be honest. So I don't know that there's really anything that did that we care about. But because it may have been a problem, we might as well, right? And so just trying to do the due diligence there to make sure we don't leave that in the code and leave it in wrong, right? All right, so what I wanted to say last was just like, hey, what is the T-blend value that doesn't produce the problem? So in the lighting code, when it produces what the T-blend value is, which would be like in here, I'm assuming we can set this to anything we want. So if we set this down significantly, Yeah, so you can see, like, you can get smoother lighting that just updates more slowly. And you still get a little flickering at the limit, right? Which suggests to me that, yeah, like, just if we just do some more sampling theory in there, we should be able to improve upon that. I don't know for sure, right? So I don't want to say that's definitely the case, but suffice to say that, it's not far. It's not far off. But it should be it should be improved. And then the interpolation is really the other thing that really needs to be improved. And also just looks wrong. Like, you can see it's kind of weirdly, like, dark in one direction and not in the other. Like, I think there's just other things we've got going on here, right, that are just a case of, like, lighting, like, quality issues. So I think we've got a bunch of stuff we're going to have to do when we want to really improve the quality, but I don't care about that particularly right now. It's fine for our current purposes. So yeah. All right. Let's wrap it up. Any quick questions? No, I agree that the lighting does seem brighter with the blendvps fix. And I mean, that was just writing into the octahedral maps wrong. So, there's tons of reasons why it might be the case that would make things appear brighter, but yeah. Is there a way to test my GLSL shader compilation success failure on other GPUs without actually having to buy a bunch of GPUs? That's a very good question. Gosh, no, I don't think so. One of the things that would be kind of amazing, is if there was a thing that allowed you to upload shaders like Shader Toy, but it ran on a farm and it, like, ran them. There was one of every graphics card in that farm, and it could tell you, like, oh, it failed. Like, here's the image that got produced from each of these, right? And then you could just see, like, did it work? Right? So, like, Godbolt for shaders would be amazing. Unfortunately, I don't think anyone's built that, and you can tell why. Godbolt can just run on a single, it can just install all of the compilers and then just run on that one machine. It doesn't need hardware, whereas the problem with the idea of Godbolt for shaders is you'd actually have to have one machine with every single graphics card in it, which is, like, literally, like, thousands. Like, there'd be, like, 1,000 machines or something, right? So, I mean, no. You certainly could try renting some time on some machines that exist in the cloud that have known GPUs to try other GPUs, but you're still only going to get a small cross-section because most server farms have a very narrow range of GPUs installed in them. It sounds like Martins is saying that there's a thing called Shader Playground that at least uses shader libraries to do some validation, which probably doesn't really help what you're saying, but it might be worth checking out anyway. I like the thing that just said, "Hello, Mr. Teapot. I am here to view your channel as was previously discussed." Why is there a view bot that came on this channel and said, "Hello, Mr. Teapot"? There is no Mr. Teapot here, is there? Stretch. All right. Well, good work, folks. We were able to fix that bug. And that was really the only nasty bug we had. The lighting still needs a bunch of improvement to it, which is really just like going through and changing some of the math to be better, right? And I think that's probably a good idea. So at some point we should do that, but I'm probably not going to do that right now because the lighting is good enough at the moment that I can do most of the stuff we're going to do. I don't really need it to be better just for development. So we can sort of take a look at that at some later date. Also, now that we've got all of the ray tracing and stuff working, we may, by the time we call Handmade Hero done, we may just move all that ray tracing to the GPU because that may just be the thing that happens. And we know that it all works. So then we could just have much faster ray tracing, at which point you don't have to really get better at sampling. Like if we could send out, 10 times as many rays, then we would just be done, right? So Star Code Galaxy, I'm going as fast as I can. I don't have anything to share. I will post an update as soon as I do. But basically, like, if you sign up for the mailing list, you will get notified. So if you go to starcodegalaxy.com and you put your name in here and hit subscribe, you will get notified as soon as there is anything to hear about Star Code Galaxy. But at the moment, no. I don't have anything to announce about that. And yes, I am in the tent. I'm in the tent that I used for recording Star Code Galaxy. It just improves the audio quality. Once I'm done with recordings for Star Code Galaxy, I will remove the tent. This is just Microsoft Edge. It's not anything. It's just the browser that's installed by default on Windows machines. So. Alrighty, folks. Thank you for joining me for another episode of Handmade Hero. It has been a pleasure coding with you. As always, if you do want to follow along with Handmade Hero at home, you can always pre-order the game on handmadehero.org, and it comes with the source code, so you can follow along with it and do your own experiments. I think we're done with lighting for a while, and we're just going to put in a bunch of game stuff now, and so that we can test it out. And clean up stuff in the engine so that we can kind of call it like here's the game, it's done. And then we can spend time just like cleaning stuff up and then like really looking at the lighting and going like, okay, what's the shippable quality version of this thing? But it's mostly working now, so I'm actually fine with it where it's at. I don't think it needs to be changed much because it gives us the information that we actually need. But if you want to keep on improving the lighting, now would be a good time to go work on just the quality of it. And you can go see like to what extent you can improve the quality with like the same number of rays cast. There's probably ways to improve the quality that you're getting back from the lighting. There may also be more bugs like the ones we fixed today, where if you fix those bugs, the lighting will improve. And so only by actually going through and putting in like specific test cases where we construct scenes, we think we know like what it should look like or whatever. Without doing that, we're never going to get to the point where we really know how good the lighting can be. So that's just kind of a separate thing that has to happen. We'll do that at some point when we want to like sort of turn the screw on it. That's it for this week. I'll be back next week for more Handmade Hero. Till then, have fun programming, everyone, and I'll see you on the internet. Take it easy, everybody.